is our data set. Like I just explained, our data set is made of 3 different variables, okay? Longitudinal information, latitudinal information,
经纬度
and we have the class of hurricane that has been created, whether it's barometer or tropical, okay?
根据它台风形成位置的经纬 you can base on some feature criteria to tell they classify them correct or not. So of course, you want to make sure they are correct or not, you must have a supervisor. That means you already know what is correct, what is wrong, right?
Definitely.
You must know what is tropical, what is power, right? You already learned something. You already learned something. So if I tell you, okay, this is a fruit. No, this is a pen. You learn something, it cannot be eaten, right? Not fruit, not vegetable. This is a pen. You learn something. This is a cell phone? No. Right? This is a bird? No. Right? Machine learning, AI machine learning. Something like the bird, they sit on the tree and tell this a human being or not. Yes? Or a straw man. Okay, I'm a bird, I'm still there. Okay, that's a human being or straw man. You based on what?
Straw man.
You based on what? Yeah, now that's of the human being. If they don't sit there, stand there, watch their cell phone. No. This is a straw man. Okay, if the person always watch stupid and their cell phone, I tell, okay, this is a human being. Okay? Even the bird, they learn something, okay?
Yes.
Even the animal, they will be tell this is a friendly person or a guy. Okay? Even the animal, they learn. By what? By their experience, by teaching, by training, or by heard, or by pain, heard. Okay? Okay, this is a file. I cannot touch.
As you may see in the vaccine example that we just took, it tells you, people try to learn more information about the virus, then you know how the virus interacts. There, you know which part that you have to target to create a vaccine, to fight against, I shouldn't say fight against because the vaccine can fight, but the vaccine can prevent, okay? So you learn and you know what to apply in order to have a better vaccine for better prevention. Now, after they try many times, because you can see, as we may know in the news, they have to pass many different trial phases. Phase 1, phase 2, phase 3, before the vaccine can get approval from the drug administration in their different countries, right? So this is all a learning process. If you don't pass phase 1, because what we are referring to as phase 1, phase 2, phase 3 trial here, in our case, in this machine learning, what does that refer to us? That refers to the testing. Because you already have the trial, and then now you're going to test it. Okay? The trial is done. Now the testing is done to make sure of the accuracy. Because, let's be clear, now we're talking about the computer. They are talking about human life. Human life, you cannot just put it in jeopardy like that. You have to try many trials. The higher the success rate, then you can apply it to real people in real life. Okay, criteria that are known in advance. This way, we can classify when hurricanes are either barometer or tropical. Okay? We already know the criteria. So, to run our machine learning, how do we do that? Okay. I'm not going to use the workspace for the first part. I'm going to do it in traditional way. And then maybe later on, I can ask you to run it to the workspace and I will come and check it for you. Okay. So, we go to data mining. Now we are doing what? Machine learning. So we We identify where in this window that we find machine learning and we click on it. Now, what part of machine learning, which algorithm are we working on right now? SVM. What does SVM stands for? Support Vector Machines. Okay? So, we click, double click. First thing you have to do in big data, in any kind of algorithm that you're going to run, is input your information in the algorithm, right? And what is your information? The variables. So let's select our variables. Now, my question to you, look at our data set. What kind of data is the longitude?
Continuous.
Okay, or? Yes. How about the latitude? Good. How about the class?
Categorical.
Now, which one is our dependent variable? Which one is our independent variable?
Class is dependent.
Okay, good. Class is what? I heard something.
Dependent.
I think I heard something say something else. Okay, so what is our dependent variable? It's class. What is class? Is it categorical or continuous? Okay. And how about our predictors? They are continuous, right? Okay. Now, because our independent variables are continuous, do we have response code for them? No, because they are numbers, right? Okay. Now let's go to the sampling. Remember, we said we have to divide our data set into
Subsample.
into what?
2 parts. Like
Okay,
testing and
2 parts, which are training.
Training and testing.
Okay, and that's where we do that, okay? Divide data into train and test sample. Usually, the most common, actually there is no specific rule about it, but the lowest I have seen thus far is a 70-30 ratio. So we are going to apply the 70-30 ratio. Okay? We trigger it down to the 70. Okay? Now, support vector machine, we use the default settings. That's good enough. The kernels, we're going to use our kernels as linear instead of RBF. Okay? And cross-validation, of course, we have to do the cross-validation process. So we tick the box. And training, okay, these parameters are good enough so we can proceed to the next step.
Okay.
So we click on.
Go back to click. Sampling. Sampling.
Yeah.
Okay. See here. If something that your data, there's a random, they will choose your randomly 7%, okay, from your data set. But if your data first 70 are learning, you can use the first n case, okay? If you put your learning or testing data at the same data file, okay?
Okay.
Maybe something that Priya, you are learning at the first 60 case or first 800 case are learning. The other will be your testing. You can use the first n case. Yeah. Or you can use the sample variable as you choose your variable. Okay? Just that you choose, 让你去选你的 learning 跟 testing 的 data. Okay?
So we proceed further. We click on OK. Now we have the first view of our data. Let's see what we have here. they tell us what we can put in the software. Okay, we said our dependent variable was class, and our independent variable were longitude and latitude. Now, because we divided a ratio of 70 and 30, they tell us that our sample size overall is 37, because we have 37 cases, right? But 70% of that 37 case amounts to 25, okay, which is the test training data, and 12 cases are considered as the testing data, okay? So it's the ratio 70-30 that is represented here. All right. Now, what is the classification type? We input this information, okay? We input them in the software. So, we ask for classification type 1, okay? And the kernel, we ask for it to be linear. These are the things that we selected. They are written here for us. And yes, we ask for cross-validation accuracy. So, the software calculates for us our accuracy in terms of cross-validation amounts to 96%. And therefore, okay, the number of support vector would be 17. Okay? But that 17 will be divided by classes, because we have two classes of hurricanes, barometer and tropical. So, barometer, support vector per class, we have 9 barometers and 8 tropical. So, these are our results that are being defined here for us. And what is the class accuracy? Because remember, we have two classes, barometer and tropical. So we have to see the accuracy per class. There is a 96% accuracy in the training data set, and an 83% in the testing set. But overall, it amounts to a 91%, which is good enough. Good enough. 91% is good enough. Now, what do we want to see? We want to see our predictions. We want to see where we were right, where we were wrong, or which one fails where. Now, for the training data set, because remember, we have two sets now. We have to select which set we are talking about. And you go here for the sample, down here. Everybody sees what I'm talking about?
Yes.
And you select the training. And then you're going to see the prediction within the training data set. You click on it. Now, here, everything seems almost correct, except here. Other than that, you tell me if you see anything that is different. Anything different? Besides here?
No.
Where we have the prediction and the dependent class. Anything different?
No.
So only this one, right?
Yes.
Okay, let's go back to our analysis again. This one was for the training set. Okay, now let's go to the testing set. Okay, and we check our predictions again. Okay, so
There's 1, 22.
yeah, we have two. We have two that are quite different. Okay? So for here, this is a very let's say, a very easy task that we had to do. This is a classification problem that we are dealing with. We are trying to classify, but this time using machine learning, okay? And the method that we are using is support vector machines. Now, using the support vector machines, what we come up with in our predictions, we found that our accuracy would be around 96%. And our result here for the training data set amounts to one case only that was not predicted well. Remember, what was the percentage accuracy for the training data set? 96. How about for the testing? 83 point something. We can verify this number, okay? Our training data set, how many cases we had for the training? 25. How many we had for the testing?
12. 12.
Now, how many cases are correct in the training data set?
24.
We can make the percentage to see if it amounts to 96%, right?
Yes.
We can easily verify that. And how many cases were correct?
10.
No.
No, 2.
10? Did you say 10 or 12?
10.
Ah, I have some English problem. Yeah, I thought I heard you say 12. Yeah. We have 10 correct cases and only 2 cases that were not really predicted well. So we can verify the percentages. 10 out of 12, I believe, would be around 83%. How about, can anyone verify that? It's easy to verify, right?
Yes.
Simple division. 10 divided by 12, right? Times 100,
Yes.
then you can have the percentage. Exactly, 83.3. How about this? 24 divided by 12 times 100? Should be 96%, right? Okay. Any important information that we would need? Let's check. We can see overall too. It depends on what you want to discuss. We always mention that for you. You can decide what is important based on your study purpose. The information that you share will be related to your study purpose. So, overall, I believe our accuracy was about 91%, which can be quickly verified. We had 37 cases to classify. We classified 34 of them correctly, okay? And 3 of them were not properly classified. So 34 divided by 37 times 100 would be giving us about 91%. Easy. And if you want to see a summary of your analysis, it's right there. You can check it out, okay? And if you want to see the descriptive statistics as well, okay, you can see it easily. This information is available for you. But again, what you will be focusing on will be depending on your study purpose and what you intend to discuss. Because no need to copy all the information from the analysis and paste it in your paper. Makes no sense. And your field of work might be different than somebody who's looking for a lot of numbers. Maybe you just need the key result for your discussion. That's it. So, in this instance, to me, the key results are my prediction compared to the observation, or based on the criteria. Because remember, this is a supervised learning case because we already knew that there are some criteria to classify between barometer and tropical hurricanes, right? The criteria, they are there. So this is not learning in the abstract. This is learning from something that already exists. So because of that, we can easily go to compare our prediction versus the observation, because the predictions are made based on the criteria that are predefined. Okay? Now, let me see if there's any reason more important result that we can
Yes, you can see the accuracy.
You can see the model.
But training.
Yes.
You can go back to your training and see your model, see your accuracy.
Okay. Let's go to the model here. You can see the weight.
Each case the
and the model specification. Okay. What is the kernel value in the constant decision in the kernel value? Okay. And you can see
accuracy.
the accuracy, of course.
You can see the incorrect. You have a highlight here.
You can do the same for the testing as well. Huh?
I have one question.
Yes.
I want to know about kernels. What is painful in this analysis when you do kernel?
What is
Kernel, yes. What is the function of
how can I explain this? What is the tenfold in, how can I explain this to you?
You mean the kernel?
Yes, kernel.
The thing,
A kernel is your function. You choose the linear or sigmoid or
like
polynomial.
normally,
Based on your distribution, what type of something like your regression. You want to use simple regression, multiple regression, or nonlinear, polynomial.
yeah,
You must have
it's
basically
related to the function, the kind of function that is used for the classification or to solve your problem. Like, let's say if
you can go back there, have a sigmoid. You can have a sigmoid. Logistic regression is the sigmoid
polynomial
function.
or linear.
So you have better some concept about your data distribution or function.
Yeah, exactly. This is mostly related to your data distribution. Okay? Maybe it's polynomial or maybe it's linear. Okay? So the classification problem is mostly related to your data distribution at the end of the day. And your distribution will be,
or exponential,
yeah, true.
or something like a sigmoid.
Sigmoid, yeah.
Okay? If are higher than 0.1 or 0, this 1. Okay? So I want to tell if 1 is a male and if a lower than probability lower than 0.5, it will be female. You can test on the probability. So this is a sigmoid for logistical regression. Okay? I tell if
Binary.
your probability lower than 0.5, so I suppose you are 0. Okay? If your probability are lower than 0.5, I mean 0.7 or 80%, I suppose you are 1.
That has a, if we can go back to selecting variables, we have a training constant of 3. Okay? So that training constant, because let me verify once more to see better what you explain. Okay. We have 37 cases, right? So
17 are your training.
yes. No. Our training was 25.
25.
25.
number of support vector. Okay.
But-
support vector.
The algorithm selects a number and creates a number of vector because to treat your data, a number of vectors are created based on the 37 cases. Now, they created like 17 vectors were created, but because we have a capacity of 3 in the training constant, so the difference between 17 and the 3 leads you to 14. So we have 14 that are bounded based on the capacity training of constant. Yeah.
Doesn't matter. You can check the help. You can check the index. You can from the help to check the index
sure.
of the definition of each parameter. Okay. You can
It's
from
at
the
top here.
help. From the help. No, the upper one, the help, your index. You can key in your index here. Okay.
Yes.
You close it and open your workspace. Open the data and choose. 接下来用那个 workspace 打开，然后做事情。Only you choose the variable and the parameter a little different. The result is the same.
How many? You see, one of you already finished and did it quite right. Now you check for the testing. This one was testing. Check for the training.
You see the kernel tab. You can choose the linear or sigmoid.
Polynomial, sigmoid, RBF.
Sigmoid or polynomial.
Yeah.
What's RBF?
I don't remember any. I don't remember.
RBF. Yep, proposition. RBF. Regression, binary.
Something like that. It's either
RBF.
regressive by
Regression, binary.
something like that.
RBF.
Anyone else did it? We have Double here who did a quick job, huh? Although I know why she did that quick job, huh? Why? I don't know. You can ask me that. But we still have that. The parameters to set up are not complicated. So if you follow the steps, you can quickly get to the result. Nothing happened to it.
No, so many
Okay,
pages.
you haven't do it.
No, I want to.
Okay. For example, if you choose another that we haven't done before, if you first 25 data are learning, the other 12 or 12, you don't need to have maybe you don't have the class.
Yeah.
Normally,
Yeah, you do
the
it in
first
class.
part is your learning data, training data, and
It will give you
the last part is your testing data. Maybe the pattern you didn't know. Yes, they can predict for
Yes,
you.
they will predict based on the based on the training that has been done. Yeah. And I believe the result would be 80% accurate. So you can expect 2 mistakes, right?
The testing data, because you are testing no result, right? You didn't know the pattern. That's what you want to predict, right? 如果你有的话，你可以 if you have the result, you will result pattern.